Okay, so what we're doing today, I want to focus on geometry proofs and kind of mix them in with what we've been doing, so it's kind of like a seamless transition. We've been doing a lot of properties lately. We've been doing a lot of like the postulates, which is what your homework is based on. That's due tomorrow. Keep that in mind. We had homework last Thursday, Friday. It was page 130. It was based on, do you know your postulate numbers, 2.1 and 2.7. That's literally what it was. It was like, when you look at a problem, what postulate is this one using? Like, what is that sentence saying compared to the picture? Okay? Today, we're going to do the near-pod idea, but we're going to look at geometry proofs, but we're going to mix them with the algebra stuff that we did today, so you can see why have I been doing everything. So there's like this, there's now this blending of like things I've been teaching you and why we actually do them. So hopefully this will make sense to you. Okay? Alright, so I'm going to click to the next slide so you can see this. Alright, here's your goal state. Is it actually turning on your nearpod?
Yeah.
Yeah.
Okay, good. And hopefully this will be working for you. Alright, I'm going to click through this. It already shows up in your nearpod, but this is just for those people who want to see it on transitions. But, or maybe it's not going to work. Let's see. Weird. Does not want me to use this today. Oh, there we go. Okay, never mind. Alright, so worksheet 2.6, we're going to work on that first. We're going to finish up problems 2 and 4. I'm going to do number 2 for you. I'm going to have you try number 4. So we'll have that out here in a second. Geometry proofs, we're going to do this today. I have a bunch of proofs picked out. I have 5 that are picked out. We're not going to get to all 5 today. I know that. We're only going to do maybe the first couple. Okay. Then tomorrow we'll finish up the last few. I want you to get a sense for how to do this because I'm going to give you homework this week where you actually have to try geometry proof for the first time. But the good news is it's a lot of just algebra steps. It's a lot of stuff you've already learned, so don't feel like you're kind of lost. Okay. We're going to be mixing the algebra stuff that you're doing to the geometry stuff, and you'll see why it's a perfect blend. Because that's like the number one thing, like doing your statement of reasons, you know, showing the work that you're doing, and actually the property names off to the side. Because I always get that question is, you know, what's the purpose? Why are we doing all this algebra stuff? Well, we have to prove geometry properties. Like we have to show why does this property work for this picture. You need to know how to show the algebra for it. If you can't do it with algebra, how are you going to do it without algebra and with letters and variables? So that's the idea. Homework due tomorrow. It's on the board over here, by the way. It's been sitting there like all week since Friday. It was page 130, 1 through 6, 7 through 9. I know that people are like, "Work? Can you just write 1 through 13?" Yeah, I broke it up by pictures. That's how I always do it. So the first 6 were on one picture. It was just a lot of the first postulates, 2-dimensional pictures. 7 through 9, I believe, are always, sometimes they're never. So you really have to think about what they're saying there. Same with like 16 through 21. It's a 3-dimensional picture. I think it's like a wedding cake, and they have like lines drawn on it. And you're trying to answer, which postulate fits this sentence. So you really just have to know what senses, what your postulates say. And then 24 through 28 is all the sometimes, always, or never. I think that's how it went. It was just kind of bouncing around. Remember, the postulates are easy. If you remember, like 2.1 and 2.3 really mimic each other. The only difference between 2.1 and 2.3, are you starting with the points, ending with the line, or are you starting with the line, ending with the points? That's the only difference between those two. 2.2 and 2.4 are about planes. Do you start with the plane and go to points, or do you start with points and go to planes? That idea, that tells you which postulate you should use. 2.5 is putting a line on a plane, 2.6 is 2 lines crossing, 2.7 is 2 planes crossing. So it's pretty easy. Like I think it's easy once you just think about it in terms of that, which postulate you should be using. So that's kind of the idea. But that homework is due tomorrow. Tuesday is tomorrow. Keep that in mind. So you might want to work on that tonight. So don't leave it at home or whatever you have. Actually bring it. Make sure you can turn it in the minute you walk in the basket. Okay? All right. And hopefully I'll give you a little bit of time today. Not very much, but I'll give you a little bit. Okay? All right. But let's jump into it. Let's do your worksheet 2.6. So have that out in front of you. Free ink away from me, please.
Don't have it.
Okay, perfect. Is that? Pen or pencil? Both. All right. Tablet worksheet 26. Should look something. Let's get rid of this. Alright. Let's get rid of the full screen idea. Let's go to my worksheet. It is. Okay, we did 1, 2, and 3 last Monday, Wednesday, Thursday. Friday was the first day we really focused on problems. This isn't yours. And the second version of it. No, that's not yours. Definitely doesn't look at your worksheet. Have many versions of this thing. That is definitely not it. I can tell by those last problems there. Let's see, this might be it. A ton of different ones. Yeah, here it is. Okay. There we go. Okay, we're gonna do number 2 today. So, have this out in front of you. Once I'm done with number 2, I'm gonna give you a little bit of time where you can actually work on number 4 by yourself. So you can ask questions, you can see how you're doing. All right, now, by looking at this problem, how many steps do you think it's gonna take us?
8.
It'll take you 8, you're correct. Now, the reason being is that it takes us 4 steps to get rid of each number. So to get rid of the 3, the negative 3 I should say, it'll take us 3 steps. You always do the opposite. So if there's subtracting 3, you're going to add it. So that'll take us 4 steps to get rid of that. Then to get rid of this dividing by 7 idea, it'll take us the next 4 steps. Now, on Friday, we had that little chart that I had, that little rabbit hole chart that told us which property do you use and when. Hopefully you have that. Hopefully you can like look that up on the notes we took on Friday. So one of the first ones we talked about was when you add or subtract. So that's add or subtract property of equality, right? Then you go to immediately the property of opposites. I call it the property of op. That leads to added identity. And then that will lead to substitution. Those are those 4 steps. Like no joke, it's the same. If you know you're adding and subtracting first, which I am here, these are 4. If you don't list 4 properties right when we start, you're doing it wrong. The most common mistake I saw on Friday when I was walking around the room checking on people's work, I think you guys had to do number 3 by yourself. I noticed a lot of people didn't put the first property. Like, what are you doing? Oh, I'm multiplying. You should write that down. Or you're supposed to be dividing. You're supposed to write division property equality first. A lot of people skip that. They're so worried about these last 3, they forgot the first one. Like what you're doing on both sides. And that's what I'm going to do here. After you're done with that, then you have to look, and yeah, we're going through another case where you have to multiply or divide property of equality. That'll lead to the reciprocal rule. That will lead to multiplicative identity. And that will lead to substitution. So it should take 8 steps, if you think about that, because we have everything we have to do here. Okay? Okay, let's go through these so hopefully you can see that yes, I am using every property name here. Hopefully this makes sense to you once we get through it. But again, these are the order. Like if you're let one person goes, Ward, I don't get the property names. They're right there. How do you not know them? Alright, so number 1, how do we get rid of the 3?
Add.
Yeah, we're going to add to both sides, right? That's your first property. You have to write the property name. So this is add property of equality. Okay, now on the right side, you know where you see the 2 plus 3. Do not touch that side. Don't make that a 5 yet. You have to wait for the last step out of the 4 that we're about to do. We're doing 4 steps. That's the first out of 4. The next steps we do are all on the left side. the left side where the number is. Okay, the last step is on the right side. So these are all on the left here. Okay, so property of opposites. -3 plus 3.
0.
0. You have to leave that as 0. That's the only thing we're doing. I'm not doing the 2 plus 3. I will save the right side till last, until I have to go to the next step. Okay? So what we just did, we did the property of opposites. You add numbers to make 0. Because again, if you're looking at the chart, or that little formula sheet that I gave you, what we're doing is we're looking at adding and subtracting positive, negative numbers to make 0. That's an inverse property. You always do inverses after you do property of equality. These are the inverses. That's what we're looking at. Okay? Next step that we're doing the identities. That's always the next step. That's what we're looking at. Okay, the identities. So, which identity are we doing next for me? Additive, right? We're adding 0. So that's m over 7 is 2 plus 3. That's the add identity. Or additive. I heard. That's what we're looking at. Now, we just got finished with the left side, right? The actual like 0 is gone. So now we can work to the right side. 2 plus 3.
5.
5. So now we're in that substitution step. This should be the last that you do on the right side. So that's the 5, like you said. Boom. 4 steps. Just like you guys said, 4 steps to get rid of one number. Now we have 4 more steps, and that has to get rid of the 7. So here's what I'd like you to do right now. Take a couple minutes, try to get rid of the 7 on your own. You know your steps you have to do, because we just got done adding or subtracting. So now you're moving on to these steps. I want to see if you can do your next 4. I'm going to walk around and check. If there's something wrong, I'm going to try to critique you on it. Okay? Again, if you have your property sheets, not a bad idea to have that out. Okay? Yeah, use that, please.
Is everybody?
No, is it working? Okay. All right, thanks. Stupid dogs. Okay, if you get done, I want to see it. I want to see how you're doing, okay? Let me know when you're close to being done, or you want me to critique an answer. Maybe you're not sure, like, I don't know where I'm at right now. I work it, I'll kind of point it out. Yep, that's fine. We'll get a property of equality. Property reciprocal, and multi. Yeah, perfect. Okay. What do you multiply by? Oh, that's a set. That's a set. Nice. Property equality. Yeah, that should be a 1. There should be a 1 up front, 1 and then multi-identity, and then yeah. So just put a 1 there, not a 0. Yeah. Easy peasy.
Can I use restroom?
Okay, so you did multi-identity, equality, 0, simple. Okay, multi-identity. is when on this left side, this makes 1. So go 1. So 1m equals, and on the other side, don't do the math yet, just do like 5 times 7. 5 times 7 plus 5 times 7. Could probably call it reciprocal multidemy. So perfect. Nice. All right, good. Good. That 7 bolted into it too. Good. Okay. Anyone else want me to double check? Trying to make sure you find everybody here. Good, nice. I think I did. All right, perfect. So, okay, good. So it looks like everyone got to that last step where you had to use these properties here. The one that I noticed, and this was over a lot of different people, when you write that first property, the first one. You guys are really good at doing reciprocal, multi-identity, and sub. Now that you know the order you're supposed to go in, the problem is the first one gets people. You're not writing down the property names correctly. And it would happen to quite a few of you in here. So we're at this step right now, right? So the first step is I have to multiply both sides by 7, right? That's called the multiplicative property of equality. So if you don't write that whole thing down, you will miss that step. So this is the multiplicative or multiplying property of equality. Multiplying property of equality. That's the multiplying by 7 idea. Okay. Now, everything we do is pretty much on the left side until the last step. You want to leave that 5 times 7 till last, and everyone was doing this right. You're taking 7 divided by 7, changing that to 1. That's the reciprocal. Okay, that's the reciprocal property. Then getting rid of the 1 is multiplying identity. So the multiplicative identity is actually multiplying by the 1. So you get m equals 5 times 7. Notice you don't have to divide by 1. You actually just multiply it, it goes away. We need that property so you don't get that stuck in that loop where you're always trying to divide a number off or subtract a number off. You can just get rid of it. That's the multiplicative identity, which a lot of you had. Actually multiplying by it. And then the last step is now you can go to the right side on your very last line and you can put your m equals 35. And that's substitution. Okay. Okay, questions at all? Okay, perfect. All right. Number 4 is when you're going to have to do on your own. Okay, that's the one that's left. I'm going to have this worksheet due tomorrow. Okay, it's due tomorrow. It's due with the other page 130. So you're going to have to do that one. It should take you how many steps in number 4? 8. It should take you 8. The exact same 8 you just did. No joke. The only things that will change, no joke, the only thing that is going to change on this problem on your number 4 is whether you're going to add or subtract first. These 3 will be the same. It's going to be property of opposites, add, identity, and sub. And then when you get down to this last step, the only thing that will change, maybe you're dividing instead of multiplying. So division, property of equality, then you'll do reciprocal, multi-identity, and sub. The 3 here never changed their name, which really weirds people out. They're like, well, we're subtracting, isn't it subtraction identity? Or we're dividing, isn't that division identity? No, it's always called multiplicative identity and always called additive identity. That's the idea. So, again, number 4 is one you're going to have to do on your own, and make sure you get that done and turn in tomorrow. It should take you 8 steps. Make sense? So we just got done with number 2. So we just finished 2, which is what you have. So 4 is due tomorrow. Make sure. Okay? All right. Let's go to the next part here. Okay, let's get to our geometry proof, and I want to do at least one of these today. I want to do one of these. Back to our Nearpod. Alright. Which one?
Or like what we're not doing during our class period.
Yeah, I think it's right. Alright. Oh, there we go. Is that showing up in your Nearpod?
Yeah.
Perfect. Okay. It wasn't showing up for me. It wasn't like clicking over. Little delay. Okay, this would be my one I want to do today. Like I said, I wasn't going to get the whole 5. I knew. I kind of just picked them out. This is a perfect blend of a geometry proof and an algebraic one. Now, does it take quite a few steps? Yeah, it does. It does. But I'm going to show you what we do in geometry so that you don't have to go, 8 to 10 to 12 steps deep. We can shorten it up and I'll allow you to do these certain things when we get to a geometry proof. You're working on this worksheet. I don't know where that worksheet 2.6 is, the one that we're working on right now. That's your kind of credit. So once you show me that you can do some algebra, now we're going to take a few shortcuts here and there. So that will shorten up your properties. Okay? All right. So first step. What we're given this material. What are these objects?
Angles.
They're angles. Okay, we're given a lot of angles there. Okay, we're given certain angles like FGJ, that's this angle, FGJ, F to G to J, that's that angle right there, that's the 6x equals 7. That's equal to JGK, that's equal to this one. And then JGK, this angle is then equal to the one next to it, KGH. Then they tell us what these certain things are. And then they want us to prove that the answer is 6. It will take us like some serious algebra to work on this, right? Do you have a question? Oh, okay, all right. So I want to show you, we're mixing algebra with geometry, but we have some new property names. Like this is something we haven't done yet. We've not officially done a full-on geometry proof. I've hinted at what we're going to do. This is a perfect blend of it. So what did we remember from last week? How do you always start a proof? Line number 1. What are you supposed to put? You don't remember what we did last week when you were doing a proof for geometry? I think we did one last week. It was like last Thursday or Friday. Did one. What was the first line supposed to be? You have to put all the givens. All the givens what you're given. Okay? So in line number 1, I have to write that angle FGJ is congruent to angle JGK. So we have to have that. We also have to have that angle JGK is congruent to angle KGH. And we're given that these certain parts. The measure of angle FGJ is a 6x plus 7, and the measure of angle KGH is an 8x minus 5. Those are all the givens. Now, the reason when we do a geometry proof, this line number 1, you should never get that first line wrong. It should be all the givens they provided you. Now, eventually, you will see that we will have to set up an algebra part here. But line number 1 should be the easiest. Now, I have no idea how many steps this will take me. Like, it's not one of those things like when I look at an algebra, I'm like, oh, that takes 4. Oh, that takes 8. If it's an expression, it could take 3 or 6, that type of thing. On geometry proofs, no idea. It could take 4, it could take 5, it could take 11. No idea. It just depends on how much work you're willing to put into it. Usually, for me, I can usually get through proofs in about 6 lines. That's probably the max I've had to do in this class. But again, that's knowing my properties and knowing how to work them. Okay, so line 1, we always write all the givens. Does that make sense? Notice, did I write x equals 6 on line number 1? No, that's the last line you're supposed to prove, not the first line. The last line is the x equals 6. Okay, line number 2. Line number 2 in my proof. Usually line number 2 on a geometry proof is reserved for redefining a word that they previously used. Like for instance, what does this symbol mean?
Congruent.
Congruent. Congruent means equal, correct? I want to write that down. So knowing that these two angles are congruent to each other, on line number 2, I can now say that they're equal. So that means the measure of angle FGJ is equal to the measure of angle JGK. Now, the little M out front means measure. So if I'm going to actually put a protractor down, I know that those numbers are equal. This is actually representing a number. This is representing a number, and I know that the numbers should be equal to each other. Also, the next line, same thing here. The measure of this angle, JGK, should be equal to the measure of angle KGH. And the whole reason why I'm allowed to do that, that is the definition of congruent. Congruent means equal in size, shape, and measure. So those angles are equal in measurement. Now, why that's important. If I know that the angles are equal in measurement, I can eventually figure out that I'm supposed to be probably setting these things equal to each other. We'll see that here in a second. We're not done yet. We haven't got to the point where we can do all that yet. I'll eventually use this stuff here in a second. Now, what I'm actually comparing here, this line number 2, what it's actually saying right here, it's talking about this first angle is equal to that of second angle. Is there anything in the second angle? No, there's not. So that isn't really helpful yet. This next line right here, this line is actually saying that this missing angle here is equal to this angle. Well, do you see that there's an overlap there? You see that both the red and the blue are both meeting in the middle. They both share that middle one. Well, that means if they both equal the middle one, so if this angle equals the middle one, this angle equals the middle one, then vice versa, this angle and this angle should be equal to each other. Because they're both equal to the same angle in the long run anyway. That's called the transitive property. It's looking at a chain of events, chain reaction kind of a thing, where one is equal to another, which is equal to another, which is equal to another, so they should all be equal to each other. So, in the long run, line number 3, this step, I'm going to start with the first angle, FGJ, out of order, FGJ, that measurement should be equal to the measurement of angle KGH. Those are the outside angles, outside and the outside. Those angles should be equal to each other. And the whole reason, step number 3, this is called the transitive property. When you have a bunch of things all being equal, the first thing should equal the last thing. How is compared to the transitive property? It's like going into the bank, handing them a dollar bill, they give you like a bunch of quarters. Okay? They give you your 4 quarters. And you walk out of the bank, you walk to another bank and go, hey, I got 4 quarters, can I have a couple dimes? Boom, they drop you 10 dimes instead of your 4 quarters. You go into a different bank, you don't want the dimes, you want nickels, they give you all their nickels, the 20 nickels you need. You go into another bank, you give pennies, they give you your 100 pennies. So, in the long run, did you end up with the same dollar? Yeah. You just transferred it, you transitive propertied it to different labels. That's all you're doing. They're all equal in the long run. That's what we're doing here. This is equal to that, which is equal to this. So they're in the first and last thing are still equal to each other. So it's called the transitive property. You're transmitting like to a new label. Now, why that's important? Knowing the first and last thing are equal, now I can actually plug in what they are. Because if you look at this, what was FGJ earlier? What was the label here that I said in line number 1? What's it equal to?
6x plus 7.
Okay. What's KGH equal to? Now I can set them equal, because I can plug them in right here. Now I can plug them in. So my line number 4, I'm going to put it over here just so you can see this. My line number 4 of this proof is actually putting the 6x plus 7 is equal to the 8x minus 5. And that's substitution. I'm plugging something of equal value into the spot. Now where I came up with this, how do you come up with that? It's taking these letters out that I said earlier, these things on line number 3, and plugging in what they were. 8x minus 5 is that thing, the 6x plus 7 is this thing, so I substitute them in. Does that make sense, like how I do it? I want to make sure on camera that I can see that. Sorry, that's mine. Okay, are we good? Okay, line number 5. Now, this is the part where I'm going to allow you to do shortcuts. I'm going to allow you to do shortcuts here to actually do math. So, to actually solve this thing out. So like for instance, to solve this for x, this is now you don't have to put like additive, you don't have to go like all through the steps like properties of opposites and identities and stuff. All I want you to do is do the simple work where you actually solve, for my numbers, right? For my x. So like for instance, I'm going to subtract the 8x to both sides. I'm going to subtract the 7 to both sides. The reason I'm doing that, I'm literally dragging them across. I don't need to put property of opposites, I don't need to do identities, I'm just going to write down what that is. What is 6x minus 8x? Negative 2x. The 7 minus 7 is gone. This is the stuff that you guys always want to do. You want to do your shortcuts, and now I'm allowing you to do that when we get to a geometry proof. You can now do some shortcuts. 8x minus 8x is gone. Negative 5 minus 7 more. Negative 12. So I did, what I just did there on line number 5 is I just did the subtraction property of equality. Because I did the same step to both sides. Prop of equality. Now, why I'm allowing you to do this, you've actually proved to me on your worksheet 2.6 you know how to do it. You know your correct steps. I could say, hey, you got to show me every line of work. That would take a long time. You guys know that. You guys had to do 8 steps. This would take you longer than 8 steps. Okay, because you have to do all the work here. Okay, so we subtracted both sides. Now, how do I get rid of the 2 in front of the x? Divide it over. So we're going to divide that 2 over. So line number 6, we're going to divide the negative 2, divide the negative 2, and we're going to write x equals 6, right? That's my last line, that's what I want to get to, dot, dot, dot. This is what I'm trying to prove, so I signify it with the dot, 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 therefore. And the whole reason why that works is because I divided both sides, so that's division property of equality. Now, I could make you back up and write the number 1 for reciprocal, then multi-identity it off, and then substitute the negative 12 divided by negative 2 is 6. I'm not going to do that. You proved to me on that worksheet 2.6, you know your real math, so I allow you to do shortcuts every now and then. Just look at this. How many steps did it take you to do the geometry proof? 6 lines of work. I said it's about 6, usually. Okay, do I know how many? No. But it's usually 6. I can usually get done before 6. But again, you do have to do a few shortcuts here and there. The ones that are non-negotiable. You should, at some point, write down what you're given, get to some formula, and then do the math from there. And you've got to get to exactly what they have. So I'm trying to prove x equals 6. Okay, we're done for the day. Done. Make sure you take your time today. Try to get the homework, page 130 done. Make sure you're working on your worksheet 2.6 and show all the steps and finish that problem number 4. Okay, that'll earn you the right where you can do some shortcuts in there.
You have some in the notebook?
Black?
Yeah.
Black.
Exactly.
Then like this one.
No, yeah.
Nothing. I'm going to apologize. I need to make a phone call.